Linear relationships is a topic that relates a line with its equation. First of all, we're going to be looking at table of values. So all of these are examples of tables of values. They haven't been completed. They all have an equation that relates the top line and the bottom line. So first of all, we'll look at this one where we've got m equals p plus 3. So our p's values are what we're given in the top line. So the first one is 1. So see how I replace the p with the 1. 1 plus 3 is 4. So that's why we write 4 in the table. Then the p is replaced by 2. 2 plus 3 is 5. 3 plus 3 then is 6. Then we're replacing it with a 7, and we get 7 plus 3 equals 10. So that's how we fill out our table, by replacing all of the numbers into the particular letter that you're told the values of. So here, each of these x values I'm going to be multiplying by 2, because 2x means 2 times x. So we can say when we times it by minus 1, we get a value of minus 2. When we times it by 3, we get a value of 6. When we times it by minus 4, a value of negative 8. Times it by 7, and we get a value of 14. So part C, each of these values here, when we substitute in, we're looking at the first one. So v would equal 6 minus 0, which is 6, minus 2 is 4, minus 6 is 0, and minus 10 is minus 4. So you should be filling this in on your worksheet that goes with this. So part D, 4 divided by 2 gives you 2. Minus 18 divided by 2 is minus 9. 21 divided by 2 is actually 10.5. You could write 10.5 and you'll get the same. They'll both be marked correct. Minus 47 divided by 2 is minus 23.5. In the next one, you can see again I've rewritten this with the times sign in to remind me that I'm timesing each of my e values by 5 and then adding 2 onto the result. So 5 1s are 5 plus 2 is 7. 5 3s are 15 plus 2 is 17. 5 5s are 25 plus 2 is 27. 5 times 22 plus 2 is 112. In the next one, we've got 3 times m, and we're taking 1 away. So 3 times 1 is 3, minus 1 is 2. Minus 2 times 3 is minus 6. Minus 6 minus 1 is minus 7. 3 times minus 5 is minus 15. Minus another 1 gives you minus 16. And then 3 times 8 is 24. 24 minus 1 is 23. So another way we can, if you don't use table of values, another way of expressing our equations, our linear equations, could be using this. So the Tn. This is shorthand notation for saying the nth term. So when I'm saying term 1, it would be like having a 1 in the top line of my table of values. So I'd substitute in 1. So here's my my formula here, or my equation. Tn equals 4n plus 1. So T1 is the first term, so we substitute in 1. So then, as you can see here, here is the equation. So that means 4 times 1 plus 1. So 4 plus 1 is 5. So term 2, I'll just be substituting in 2. Second term. 4 times 2 plus 1 will give me an answer of 9. So the second term using this particular pattern will be the number 9. If I wanted to find the 50th term, I just substitute in 50. So 4 times 50 is 200. 200 plus 1 is 201. So you can find whatever particular term in a number pattern that you would like just by substituting in the term that you want into the actual pattern's equation. So let's have a look at a particular pattern. So here's my pattern. What would the next term be for this pattern? Well, you can see it would be 31 because each time we have added 6. So 7 plus 6 is 13, 13 plus 6 is 19, 19 plus 6 is 25. But if I want to find the 60th term, it would be really hard just to keep adding the 6 on each time to work out what the pattern is. It would be better if I had my rule where I could substitute in 60. So a way of working out your rule could be this. I find it easier to have a table of values. So to have, first of all, we need the nth term, so we can just substitute in 60. So for my table of values, my number, my term number, so the first term is 7, second term is 13, third term 19, and fourth term 25. So I need to write an expression that relates the top and bottom line. I need to find the equation. So on the last questions we were given the equation and asked to find that, substitute in the top value to find the bottom value. Now I've got all that done and I'm going back to find what the equation is. So basically we know that because each of the numbers go up by 6, this gives me the little hint of that it's going to be 6 times the number and then plus or minus something. So what I mean by that is my term n will be 6 times the n, because I'm using the number n for the top line, but plus or minus some other number. So let's check. 6 times in the first term, I've got 6 times the 1 will give me 6. What do I need to add on to get 7? I need to add on 1. 6 times 2 is 12 plus 1 is 13, so that works for that one. 6 times 3 is 18 plus 1 is 19. 6 times 4 is 24 plus 1 is 25. So you can see the rule works for each of the pairs in the table. So that means this question mark here has a value of 1. So here's my equation. So how do I find the 60th term? I substitute in 60 for the n. So that would mean I'd have 6 times 60 plus 1. So that would be my answer. Okay, question number 4. Oh, before we get to that, sorry. Just a little note on helping you to find the actual equation. So what I did there, when the values in the top row of the table are consecutive, so if they go up 1 by 1 each time, then you can use the number pattern from the bottom row to find out the multiplier. So in the last question it was 6, but here you can see it's going up by 4. So that means the numbers, the formula has a multiplier of 4. So the formula will begin with y, in this case at the bottom, equals 4 times x, because x is on the top. And then we've just got to work out whether we've got to add or subtract a number. So to work that out, we need to test the pairs, and we need to make sure it works for more than one pair. So here, if I did my 4 times x, so 4 times 3 would be 12, what do I do to the 12 to turn it into a 5? I need to take 7 away. Then I could pick another one. Say this pair here. If I did 4 times 6, I would get 24. 24 minus 7 would give me 17. So the minus 7 pattern works for more than one pair. So I can say the formula is y equals 4x minus 7. So using this idea, let's have a look at it, an example. Question 4, you can see here, I've got my animations. We're going down by 3 each time. So because we're going down by 3, it's minus 3 here as our multiplier, and then we've got to work out what we've got to add on. But when I do multiplying by the first, second, third and fourth term here by the negative 3, I actually get this number. So I don't have to add anything on. See, minus 3 times 1 is minus 3. Minus 3 times 2 is minus 6. So there's no actual difference here. So I don't have to add or subtract anything. So I just write term n equals minus 3n. In the next one, number 5, you can see that we've gone down by negative 2 each time. So that means my multiplier is negative 2. So then I've got to say, okay, what do I have to add or subtract? So set it up and think, okay, minus 2 times the top number of 2 gives me minus 4. What do I have to add on to that to get to give me 0? I have to add 4. Check it for another one. You might go minus 2 times 3 is minus 6. Minus 6 plus 4 is negative 2, and it will work for these other ones here. So that's why the n there, sorry, that n should be a d. That's why I've got minus 2d plus 4. Thank you.